potential energy and work done story that we had was simply if we have two charges Q1 and Q2 at a distance of r, we can say the potential. We can say that the potential electrostatic potential energy of this system is nothing but the work done to bring the charge Q2 from infinity. Right?
Yes, sir.
Work done to bring Q2 from infinity is nothing but our electrostatic potential energy, and we got the electrostatic potential energy as K Q1 Q2 by R. It's a scalar because energy is always a scalar, so we are not worried about the direction story, right?
Yes, sir.
Now, suppose I have two charges, Q and Q. Okay, this is x-axis, this is y-axis, and take this point as minus a comma 0 and this vertex, this point as plus a comma 0.
Yes, sir.
Now, I am bringing a charge to Q from infinity to a point 0 comma 2a.
Yes, sir.
Find the work done to bring the charge to Q from infinity to this particular point. Let's say this is A, this is B, and this is C. So from infinity to point C. Okay. Find the work done to bring the charge to Q. So I'll just solve this one. Okay.
Yes, sir.
I'll just solve this one. So the same situation here is happening with two charges. So what we will do is, so the work done to bring a charge from infinity to this particular point is the same as the electrostatic potential energy of these two charges. Correct?
Yes, sir.
Similarly, the work done to bring this charge from infinity to this point is the electrostatic potential energy of these two charges.
Yes, sir.
So, my
The
work done,
resultant will be down,
that will be,
downward minus.
that will be downward.
Yes, sir.
What will be downward? Who is
The
that?
resultant of the two potential energies.
And energy now suddenly has a direction.
No, sir.
Yeah. So come back. The work done to bring this charge to Q from infinity to this point is the electrostatic potential energy of 2Q charge and Q charge.
Yes, sir.
Right? So that is basically K 2Q into Q divided by, what will this distance be? A root 5, right?
Yes, sir.
This is A, this is 2A, therefore it is A root 5. So I'll have A root 5 over here, correct?
Yes, sir.
This is one half of the story due to this charge. Now due to the other charge, the work done to bring the charge from infinity to this is basically the electrostatic potential energy of this system, that 2Q and this Q, right?
Yes, sir.
Due to symmetry, I can simply say it is into 2, correct?
Yes, sir.
Is this clear?
Yes, sir.
So I can say the potential energy of this system, okay, which system I'm talking of? Q2Q and another Q2Q. Okay.
Yes, sir.
Q2Q, Q2Q, these two systems. Is the work done to bring the charge 2Q from infinity to point C, correct?
Yes, sir.
Is equal to nothing but 2 into 2 is actually 4 in the numerator, right?
Yes, sir.
Is nothing but 4
4Q.
times KQ square by A root 5. Okay.
Yes, sir.
Before the 2Q charge, now I'm extending this question. Before the 2Q charge was brought from infinity to this, the charges Q and Q were already present.
Yes, sir.
So the potential energy of the charge Q and Q system is what? K Q into Q divided by what is distance between them? A plus A. It's 2A. A plus A is 2A.
Sir, so we are considering the work done to bring Q to Q.
Correct. The potential energy of the system Q and Q is nothing but the work done to bring this particular Q from infinity to this point.
Okay. Yes, sir.
Right? The question is, what is the work done to bring 2Q from infinity? But I am discussing a whole particular situation here, complete situation. First, we discussed whatever is the question. Work done to bring
Yes, sir.
2Q from infinity to C. So work done to bring 2Q from infinity to C, according to this situation, is the potential energy of the system of these 2 point charges at A and C.
Yes, sir.
Plus
Even
these
C
2 point charges B and C.
Yes, sir.
Now, therefore, the total work done to bring 2Q from infinity to point C is this. Correct?
Yes, sir.
Next, I moved on by saying we can also discuss about the potential energy of a system of charge Q and Q is this.
Yes, sir.
Therefore, just an extension of, so we are already done with our question over here, but an extension of this, I can say the total potential energy of the system, entire system, who all are there in system? One 2Q charge, Q charge and Q charge, correct?
Yes.
CAB. Okay, at point C, at point A, at point B.
Yes, sir.
Total potential energy of this system is the potential energy of the system of this. Let us say this is some U1. Okay. So system 1 plus this particular thing, I'll call it as 2. So basically U2.
Sir, why can't we even take it as from point A? Like there's a Q charge over there. So that from infinity to there. So we have to add one more time.
What is the potential energy of a point charge placed at a particular point? Right?
Yes, sir.
First, I had this Q charge. So first I have to bring the Q charge from infinity. Correct?
Yes, sir.
You are asking why are we not considering the energy to bring the first charge from infinity?
Yes, sir.
Because there is no force acting on it. I have to work on some system when there is some resistance for my work.
Yes, sir.
To bring a charge, single charge, from infinity to any point, how does it
Yes.
matter? There is no meaning of the potential energy of a point charge placed at a point.
Yes, sir.
But when you have already a point charge and now I am bringing another point charge Q from infinity to this point, I have to work against the electrostatic force.
Yes, sir.
Right?
Yes, sir.
So therefore now potential energy of system of charges comes into play, but potential energy of a single charge has no meaning in it. Single point charge has no meaning in it.
Yes, sir.
Is this clear?
Yes, sir.
So that's why my first bringing one point charge has no meaning to it. But when I already have one point charge and now I am bringing another point charge, then these two will have a potential energy of themselves. Then I am bringing third point charge. Then these two and these two will have a potential energy.
Basically, the point charge at A is constant. I mean, it's at rest.
Basically, the point charge at A is at rest. All point charges in this situation are at rest. Because
I mean, after bringing it from the infinite.
yes, even this also is at rest. Because if you leave this system now, they will all run away from each other.
Yes, sir.
So we are fixing all the point charges once we bring them.
Yes, sir.
So here what I am discussing is the work done to bring 2q from infinity to this point can be discussed as the potential energy of these 2 point charges and potential energy of these 2 points, right?
Yes, sir.
Then I extended it further, saying that these 2 point charges will also have their own potential energy, which is this.
Yes, sir.
And then all the three together, we can write the total system of 2q, q and q charge will have a potential energy, and that potential energy will be the summation of this and this.
Yes, sir.
Okay, so u system of 1 and u system of 2, basically if I'll add these two, I will get the total energy of the system. Okay, so I'll take kq square by a outside. The first one will have 4 by root 5 in it, and the second one will have 1 by 2 in it. Is this clear?
Yes, sir.
Xerox. We will discuss one more question on this. Hello everyone. Welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG and other competitive exams. If you're interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video.
Sir, I just want to confirm that, I mean, before bringing the two charges from infinity, the the charge at A is staying there only. I mean, it's at rest. Before bringing
Yes, it's at rest. Yes.
Yes, sir.
It is fixed, we can say.
Yes, sir.
Okay. Leave it. We are making a story right now. Okay. First, I have a charge Q at a point A, which is minus A comma 0. Now, this charge to be placed at this point in itself has no story, because you will have potential energy of a system of charges, not of a single point charge.
Yes, sir.
Because it will not make any sense by itself. So I am taking a point charge in a free space. Everywhere it is free. I am taking a point charge from one place to other place. It does not have any electrostatic interaction with anyone else. Therefore, it makes no sense if what is the work done to place it over here. Has no sense. Okay.
Yes, sir.
So first point charge is placed at point A. It has a charge Q. Great. Till now we have nothing to do with anything. Next, I will bring a charge 2Q to the origin, from infinity to the origin.
Yes, sir.
Now, what is the work done? Work done to bring the 2Q charge from infinity to origin point O is nothing but the electrostatic potential energy between charge Q and 2Q. Okay?
Yes, sir.
Let us call it as 1. Okay?
Yes, sir.
Which will be how much? It will be K Q 2Q divided by A.
Yes, sir.
So we can write this U1 fellow is nothing but 2KQ square by A. Correct?
Yes, sir.
Bringing the second point charge in the story. Now bringing the third point charge in the story. Now I'm going to bring a point charge to a point C, and let's say this coordinate is 0, A, and let this charge have 3Q. All are positive charges for now. Okay?
Yes, sir.
What is the work done to bring 3Q charge? Work done to bring 3Q charge from infinity to that point C. Right?
It will be due to A and due to O.
Due to A and due to O. So electrostatic potential energy between Q and 2Q, between Q and 3Q, right? Correct?
Yes, sir.
Electrostatic potential energy between 3 and 3Q. I'll call this as 2. And also the electrostatic potential energy between 2Q and 3Q. Correct?
Yes, sir.
And let me call this as 3. Okay?
Yes, sir.
So, how much will this come as? K Q 3Q. What is the distance between Q and 3Q? A root 2.
Yes, sir.
Plus K times
A
2
2Q 3Q upon A.
A. Fine?
Yes, sir.
If you understand the story, the work done by me to bring the charge, the work done by me to bring the charge from infinity to this point, and the work done by me to bring the charge from infinity to this point is the potential energy that is there inside the system.
Yes, sir.
Right? So I 10 joules of energy to raise this marker. Now this marker has 10 joules more than what it had.
Yes, sir.
Similarly, initially this entire story had 0 energy. The work done to bring 2Q charge from infinity to O, and the work done to bring 3Q charge from infinity to C, it is that this entire work done is stored in the system.
Yes, sir.
That itself will eventually come as the total potential energy of the system also.
Yes, sir.
So while solving, we should be sure of the stories that we are discussing. So the total potential energy of the system is potential energy 1 plus potential energy 2 plus potential energy 3. Is this clear?
Yes, sir.
But the work done to bring the first charge is this, and the work done to bring 2Q charge is the first one, and the work done to bring 3Q charge is these two together.
Yes, sir.
Clear?
Yes, sir.
And the addition of all of it will give me the total potential energy of the system. So I'll take KQ square by A common because it's common everywhere.
Yes, sir.
We will have 2 plus 3 by root 2 plus 6.
Yes, sir.
Clear?
Yes, sir.
Xerox. Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.